Okay, greetings everybody. Today I will talk about Apache Ignite Spark integration and how this integration can help with Spark data processing. Let me speak a little bit about myself. I've been worked at GreenGain since 2017 in the customer solutions team. As part of this team, I have been involved in various activities related to Spark integration, such as designing complex Spark jobs for data loading and data reading. I have been working for cross-database Spark queries, and also I run some benchmarks for a large amount of data. And today we will speak about it. In this webinar, I will share with you some experience that I have gained during this time. And I guess it can be especially useful for people who are going to use Spark with Apache Ignite or GreenGain. And probably it will be also useful for people who already have Spark and want to optimize this solution. Let's take a look about agenda. My current talk will consist of several main parts. First, we will create an environment. Yes, I will describe what was done. So this environment will includes configuration of HDFS, Spark, and Apache Ignite. And also I will describe a few tips that can help you with these configurations. After that, we will take a look at the existing Apache Ignite Spark integration API and discuss the examples that I will show to you. Then we will discuss a little bit about different optimizations for Spark and Apache Ignite, and finally run the demo. Demo will contain several examples that I used during benchmarking of a large amount of data. So we will see some real results for these benchmarks, and after that we will take a look about results that I got from the query started on large amount of data. Let's start from the environment overview. On current slide, you see a diagram for our deployment. So I prepare the separated AWS deployment. In this deployment, we will have several AWS hosts. One of these hosts will be a master host where we will have HDFS name node, Spark master, and Apache Ignite server node. Also, we will have workers hosts that will have HDFS data nodes and Spark executors. Finally, we prepare special ELB load balancer, Elastic Load Balancer, that we will use for Apache Ignite IP Finder. So it's a special way how each node of Apache Ignite can say about its IP addresses to another node. All this solution will be deployed in isolated network, and only several ports will be opened to my IP that I have right now. These ports are 22 port for SSH, 8080 and 8081 ports for Spark, 9870 and 9864 for HDFS UI. Okay, it's clear. Let's go to the next slide. About isolated network. Isolated network will be configured in AWS using special items that named security groups. On the current slide, you see the example of such security group, and you see that we have several open ports for some IP address that is my IP. And also we have a special restriction for traffic for some security groups. So you can see that security groups has 9733 at the end, and all traffic will be limited to hosts started under this security group. So it means that it's not possible to connect our cluster or our Spark or HDFS clusters from external network. According IP Finder that I mentioned before, you can see on the screen how it works. So we have several properties, for example, region and name of the load balancer we created, and some AWS credentials. So using this information, we can set up this IP Finder for your Apache Ignite server, for example. And when you start one more node, this node will connect to this load balancer and get the information about all other nodes that use it. So it will get all the information and will know how to connect to another node. Okay. Also, we will provide a special user. In my case, it will be GG user. We will provide SSH key of this user to each host, and also I will load private keys to each host. It's requirement for HDFS because to simplify the deployment, I set up SSH without password. And yeah, so I did some other optimizations like setting the correct ulimits, disabling IPv6 addresses, and allowing interaction between hosts and some others. All these things were automated by Ansible tool. So later at the end, I will show you the project in GitHub where all these Ansible scripts and examples will be available for you. Okay, we completed this environment overview, and now we can begin a review of main aspects of Apache Ignite Spark integration. First of all, let's see how it works. Yeah, in this diagram you can see the Spark job that was created by some user, and this job was sent for execution on Spark master. Spark master will create a special application that names Spark driver, and Spark driver will first it will collect the information about all available executors that we have in our deployment, and then it will send some part of this task, of this job, to each executor. It will be done in map-reduced view, so each executor will complete some task and return some result of Spark driver. Also, you can see that using Apache Ignite integration, each such executor will also start Apache Ignite client node. You can see it on the screen. And this client node will be able to communicate with standalone Apache Ignite clusters that can be located outside Spark hosts, for example. If this job will, for example, load some data to Apache Ignite, each executor will load some part of this data in parallel. Okay, I guess it's clear. Let's now see how to understand how your code will be executed. In this example, we create a data set which reads the data from the CSV file on the disk. After that, we will choose only 4 columns from this file, make sort operation using the ID field, and get only first 10,000 of entries. So to see how it works, you can run a special command in Spark explain, like you see on the screen. When you run such command, you will see something like this. So you will see a lot of execution plans. You can see that we have parsed, analyzed, optimized, and physical. All these plans are results of some Spark optimizations. And the most important for us right now is a physical plan. So physical plan will show you the results for execution after all possible optimizations that were done by Spark. Exactly in this case, this plan shows us the following. So data is read from CSV file. On the disk, you can see it via command file scan CSV. After that, only several several columns will be used. So you can see ID of each column in output of this command. So for example, for ID field, its ID will be 10. For name, it will be 12. City ID will be 11, etc. After that, you can see that we have order by ascending using ID field that has number 10, and we have a limit 10,000. So we will make some sort. So using such explain command, you can clarify how every data set was created in your Spark job. It can be very useful for debugging. Okay, now let's go to APIs that we have in Apache Ignite Spark integration. First of all, I want you to describe that each this API will be matched on some Apache Ignite API. For example, when we work with IgniteRDD, it will have only two values. One value will be a key, another value will be a value, and it will be matched to cache value API in Apache Ignite. When we work with DataFrame, we will not have any key or value because DataFrame is a representation of relative SQL table, and it can be easily matched to Apache Ignite SQL table. So, and you can see that IgniteRDD instance will be matched to pair RDD in Spark, and DataFrame will be matched to some dataset collection in Spark. Okay, let's take a look at some examples. First of all, example for Apache IgniteRDD. What you can see here. So each job started from Spark session. Yeah, Spark session is some kind of Spark context that contains some properties that you can provide to each job. Using this Spark session, we read data. In this case, it's a CSV file located in HDFS. When we read these records, we need to transform it to Java pair RDD. It's Java code, so it's Java pair RDD, and it can be done using map to pair function. As a parameter for this function, we should create a special transformation function. In this case, it's transform data function. We will take a look at this function a little bit later. And finally, using this Java pair RDD collection, we can create IgniteRDD collection that based on test cache in this case, and we can just store that pairs from Java pair RDD collection to this cache using save pairs command. Sorry. Okay. On next slide, you can see the explanation. Yes, so you can see a Spark session, what it is, Java RDD or just RDD in Scala. It's a special collection in Spark that is immutable. Map to pair functions that create Java pair RDD from just RDD, and Java IgniteRDD is a class developed by Apache Ignite and save pairs. We discussed it on previous slide. Okay, accordion transformation. Yes, so for each data model that you're going to store into Apache Ignite, you need to create such function. For example, you have one CSV file with some fields inside. So you need to prepare some transformation function for this file. In case if it will be changed, you need to write another transformation function. Here you get this RDD collection that contains strings from CSV file, and we split these fields because they have a separator. One field will be used like key. In our case, it's long. Other fields will be added to special object, test data and try. And both this long and this test data and try objects will be like key and value for arrow cache. So we will return from this method tuple2 with two values that we mentioned above, and later this collection after transformation will be stored to Ignite. This is a flow that IgniteRDD has, and you can see that it's pretty complex because you need to prepare this transformation each time. And for example, in case if your source has a lot of fields, it can be real hard to implement such function. Okay, but it's not so bad because we have another solution. It's Ignite DataFrames. In this case, it's pretty simple. Spark can read the same CSV file, but it will be presented like a data set. Data set will be based on some model with columns, and we can easily make some selection, filtration, etc. using these columns. Even we can run some SQL queries using this data model, data presentation. And that's why we can easily transformate this to SQL. You can see that in current example, we read the file. After that, we made some selection. So we choose only 4 columns. And we just write these entries to person table in Apache Ignite. So that's all. Let's take a look a little bit closer. So yes, DataFrames. Yeah, DataFrames in this case will be like a special presentation of table in relational database, and it means that it provides some kind of request like SQL, and we can use it. And special class in DataFrame writer can transform this entries to Apache Ignite SQL table. So like you saw on the previous example. And flow in this case will be more simple. So you just need to prepare the Spark session with required properties. After that, you need to prepare some data set. It can be CSV file, it can be some data from HDFS, it can be other sources. And when you create a data set with some model, you can easily store this data set to Ignite using DataFrame writer, or for example, read something from Ignite using DataFrame reader. It's much simple because you should not create any transformation functions this time. So everything will work just using this representation that can be mapped to a SQL table, for example. Okay, so we have finished with a review of environments that we use, and we investigated the APIs that we have in Apache Ignite. So right now we can take a look a little bit at possible optimizations that can be used for Spark and Apache Ignite. Okay, at the beginning of my talk, I mentioned that we run some benchmarking, and during this benchmarking, we use the following properties. We used more, but I guess it can be like a main. So let's take a look at them a little bit closer. First two options are related to how heap size will be managed in Spark. When we set these options, we can choose the part of memory that can be used, for example, for storing data, and which part of this memory that we will use for storing data should not be evicted. It's a little bit better described on this slide. Yeah, so you can see that we have three regions in Spark heap memory. We have some reserved memories that we can change. And also we have a user memory that you can use, for example, to store your objects during Spark job. And also we have a Spark memory. Spark memory can be separated on two parts, execution memory and storage memory. Okay, and Spark memory fraction can set how much we will use for storage memory. Yeah, by default it's 75%, but it can be changed. Other memory will be used for different calculations. Yeah, and in case if you need to, for example, store some memory without any eviction, you can also set another property. It's Spark memory storage fraction. It will choose which part of Spark memory will be used for some kind of data that should not be evicted. Okay, and when you will change these two parameters, you can get great results in case if you understand how it should be optimized. For example, if you don't need a lot of memory for execution, but you are going to provide this execution under a huge amount of data, you can decrease execution memory and increase storage memory. It's like example. Let's take a look at other options. Storage level. Storage level is a special parameter that you will use in case if you will persist some data set, for example. How it works? For example, in your Spark job, you are going to do a lot of calculations under some data set. And in case if you will not persist this data set to Spark memory or to Spark disk space, you will also read this data set from the source each time when you are going to work on it. It can be a little bit slower. And in case if your situation is similar to that I described, you can use a special method that we will see on the next slides and choose where it should be stored. So exist several storage levels. On the screen, I show you of heap. So in case if you will turn on of heap memory and set the size of this heap memory, you can use it. Also, you can choose storage level memory, memory and disk, and just disk. So during this property, it can significantly decrease the time of your calculations. Okay, next is standard parameters that I guess everybody use. Spark driver manager and Spark executor memory. Sorry. So it's the size of heap memory that will be available for driver and executor. It's clear. Of heap size, it's also clear. So it's how many of heap will be provided to each executor. And the next property is pretty important. So in case if you are going to run some calculations, you probably need to configure your garbage collector. Yeah. And using this property, you can provide different properties for GC, for example, and it will be used by executor. And the last one is about scheduler mode. So it's when your Spark context will be shared between, for example, several services, and they all will send you some jobs for execution. You can choose how these jobs will be executed. By default, they will be executed in first in, first out mode, but you also can use fair mode. In this case, this task will be load balanced between all the executors. Okay, we speak about this slide, and this is the example that we used for benchmarks. You can see that we have a lot of other properties here, but most of that I described, you can see here. Okay, I will not take a lot of attention here. Let's go forward. Okay, other things that can make your Spark job faster. First of all is the order of data. For example, in case if you will read some data from HDFS, it's really important, is this data ordered or not? In case if data will not be ordered, reading of such data can be very slow. So it's important to check how you insert the data into the HDFS, sorry. Okay, next property we discussed before, it's caching. Yes, so you can see, for example, that we have some data set and we run persist method and choose a storage level. So as I said, it can be very useful in case if you do a lot of similar calculations under the same data set. Yeah, so we also discussed about memory fraction and storage fractions that can help you, for example, to avoid frequent disk swaps. And the last one is a repartition method. So how it works? When you are going to do a join request, join SQL query, you will have a field which will be used for join. For example, if we have company and person SQL tables, and we have a join using field ID in company and person, company ID in person, will be great to have these entries with the same fields in the same partition. By default, it's not working, but when you call a repartition method, it can change the location of entries in Spark, and in this case, your join will work faster. So, but this repartition can also take some time, so you should take into account that it can be a long operation. Okay, let's go forward. How Apache Ignite can help? Yeah, so first of all, we speak about repartition. In Apache Ignite, we have data collocation. It's the same, but it's a part of configuration, and each time you insert the data, this field that named affinity K will be checked by special affinity function, and as a result, we will get a number of partition where this entry should be stored. Yeah, so and person entries and company entries with the same fields, with the same values of fields that use and join will be located in the same partitions. So in Apache Ignite, it works out of the box, and you should not spend your time on this repartition method. Another bonus is SQL indexes. It can be used for just SQL when you try to use some field. So you can easily find the correct entries using B+3 structure that used by indexes, and also it's used for joins, yeah, because you can create index for join, and it can significantly increase the time you spend on these queries. Okay, by default, Spark don't support indexes. So let's go next. Okay, we are ready to run the demo. So right now I will turn my screen to another tool. So we have a project. Yeah, so this is a project that I will share with you. You can see here several scripts. We will talk a little bit about them, but right now I suggest to use one of them. So I have already deployed my hosts and create a security group and configure it. Spark, Apache Ignite, and HDFS on that hosts. Right now we need just to start it, so we can use a special script that has name startup tool. Okay. Okay, so right now we have execution for Ansible script. It can take some time, but during this time we will do some steps. For example, on your screen you see that we format the HDFS. Right now we start our HDFS master node, name node, and workers, and all other stuff that HDFS has. When it will be completed, we will be able to open UI ports for this. Okay, let's do some quick review what we have in the scripts like Ansible. Yeah, I'm not sure, can I make it bigger? No. So each such script contains of several parts. We have a main parts that create a flow. So it describe, for example, on which host it will be started. In this case, it's launched. Launch host will be taken from special file, and this is IP address of master node that I mentioned at the beginning when we see a diagram of our deployment. And we see some roles, some property files and some roles. And for example, here you can see what we did for our hosts. For example, first step is install GTK 8. Next step is install additional software, create GridGain users, make some updates in system, generate special folders, and download GridGain and make a restart, yeah, to apply some SSH keys. After that, the same we will do for HDFS, we will install it, and finally we will do this for Apache Ignite Spark. Well, just Spark, sorry. Okay, we completed with starting, and now we need to make SSH access to that host. So during my provisioning script that I showed you right now, we load our examples here. So you can see that we load my key, different configuration files, some start commands for our Spark jobs, required binaries, and other stuff. For example, in case if we will take a look at some example script, like example 1, for example, you will see that we will use Spark submit. Master will be started on port 7077. Class that we will use has name Spark HDFS loader multithreaded. I will describe what this class will do. And also you can see some parameters. Let's start first. 1 second. Yeah, first command. So we will use bash, and this example 1. This example will load 2 Parquet files in HDFS system, and each file will has 10,000 of entries, and it will be done using Spark. Okay, it can be a little bit long, so but you see that we load 1000. Okay, now we load 2000, 3, etc. And when we will load 10,000, we will stop. And this data will be located in HDFS. Okay, now we can run second example. This second example will load data from HDFS to Apache Ignite. So all these examples you will be able to see in a repository that I will share with you. Okay, let's run second example. So now Spark will start a separate Ignite client, and using this client, it will load this 10,000 of entries from each HDFS Parquet file to Apache Ignite SQL tables. Okay, so you see that we have one server right now, one client, two clients, because we have several executors, 3 clients. And yeah, loading is started. Okay, it's done. So we have all these entries inside Ignite, and now we can run some benchmarks. For example, first benchmark will do the following. It will not use Apache Spark. It will use only Apache Ignite. So we will just start a separate client and run SQL Query using our SQL Fields Query class. It's our SQL API. Let's start it. Okay, so new client was started. Okay, so you can see in output what we have. So we have 10 warm-up iterations and 10 iterations that we will use like a benchmark results. So in this case, what's up? Yeah, in this case, you can see that warm-up latency, yeah, and real latency. It's part of benchmark environment. For example, you can set 10 warm-up iterations and 1000 iterations for benchmarking, and you will see percentiles in output. So in case if you will use this project, you will be able to change these parameters. Right now, we see that during client start, we have a bigger time, but the average time of execution is about 50 milliseconds. Now let's run this query using Apache Ignite Spark integration. So it will use DataFrames, and we will just join to DataFrames using Spark. So data will be read from Apache Ignite. So first time we use 50 milliseconds. Let's take a look how much we will have right now. And it will be slower, of course, because we have some we have some additional calculations that Spark can provide to us. So okay, you see that it starts some calculations. This time is spent because of each executor start a separate Ignite node on it. Right now, all nodes are started, and you see it's a little bit faster than at the beginning. Let's wait for some time. Okay, so results. When these clients were started on each executor, it spent 9 seconds for the query, but after that, it's become about 300 milliseconds. Okay, let's run the next example. So I don't do any optimizations for like indexes, etc. So it's just clean experiment. Okay, examples number 5. In this example, we will cache the data from HDFS in Spark memory. So we will persist it and run SQL over persisted data in Spark. Let's see on the results. Yeah, it's also can take some time. Okay, yeah, it's begin calculation. In this case, we don't spend any time for startup of Ignite nodes. But you see that we still use a lot of time at the beginning, at the first iterations of SQL Query, and it's related because, as I said before, first time when you read a data set in Spark, you read it from the HDFS, from the disk, and this 8 seconds is a reading from HDFS. After that, its work must faster because next time we read from the memory, not from the disk, not from the HDFS. So from the HDFS, it takes 8 seconds for reading, and the average result for this query when it's cached in the memory is 400 milliseconds and a little bit more. And if you take a look at previous example, okay, we can't. It's a little bit slower than when you use Apache Ignite, maybe on 50%. Okay, so last time we have 300 milliseconds, now we have 460. And last one, when you don't use any caching, yeah, so this caching can take some time, you see, but last example will be when you read data exactly from HDFS each time. So this example will be longer than previous because reading from the disk can be very slow. In this case, we made the data in HDFS ordered by the field that we use. And okay, so it can take maybe 1 minute. And during this time, we can take a look a little bit about on the classes that we run right now. Let me change the screen. Okay, I hope you see this. This is a demo repository that I will share with you. It contains this scripts that I used for creation of my environment. Here you can see that we have 2 nodes, yeah, and these nodes used our security group that I mentioned before, that was created by one of this script, and this is scripts that you can use for creation the same environment. I prepare the README for you. You can run these scripts using this README. And here is the project that we run today. Let's take a look. Yeah, so this is the classes. First time when we load data into HDFS, we use this class. And you can see that we create 2 threads. One thread use generator person task, and second use generator company task. Each task create a data frame and put the data into the HDFS in Parquet mode, so in Parquet format. Okay, second example was, sorry, not this, was just reading the data from Ignite. So we create SQL fields query. Yeah, this is our query, and we run it several times for warm-up and several times for benchmark iterations and print the output. It's pretty simple. After that, we read data using Spark integration, this one example. So we create two data frames from Apache Ignite. One data set was from person table, second data set was from company table, and we made a join between them using the column ID and column company ID, and do the same a lot of time and print the result. After that, we read cached data. We run this class. In this class, we get a data set from Parquet for person. After that, we make persist operation, memory only. The same for company, memory only. And we run the iterations. And you see that first iterations were slow, as we saw before. But when this data was cached, it becomes faster. So logic is clear. And the last one is reading from exactly HDFS. In this case, we have logic like we have for reading from Ignite, but the source is different. In this case, we have, sorry, it's not that. One second. Maybe it's not correct class. Yeah, I guess it's copy. It's loader. It's loader, sorry. This one, yeah, of course. What we have here, we have a person that we read from Parquet file. We have a company that we read from Parquet file, and we have the same syntaxes that we have in Apache Ignite example. So we make a join using two fields, company ID and ID, and just run show to return the results. Okay, that's about our examples. Let's back to results of HDFS. Okay, you can see the examples. In this case, first iterations when we read data in such way were about 20 seconds. I'm not sure why, but after that it's become faster. Probably we spent some time on some initialization of Spark here. I don't know. But after warm-up iterations, you see the average results, and it's about 2 seconds. Yeah, greater than 2 seconds. And if you remember, when we use a clear Ignite, it was about 50 milliseconds. So it's in more times faster. And other two variants, when you just read Spark from Ignite, or when you cached the data from HDFS and after that execute a query on this cached data, both that variants are faster than this one. But when you cache data, you also will spend a lot of time for caching. So because caching is the same like reading from HDFS, and it can be slow. When you work with Apache Ignite, you don't need to persist anything, so it will be executed without this operation. Okay, so it's our results that we got on this environment. You should understand that this environment are pretty poor, so we don't have a lot of CPU, and this disk are not very good. But right now, let's back to the slides. Okay, one second. I need to find my mouse. Yeah, so yeah, some details about what we did. So we load data from two tables, person and company. This is the JVM properties. Tables were collocated for benchmarks, but in our case, we have only one server node of Apache Ignite, so it's not important. And yes, this is the example. We see this, and this is the query. So we made some join and additional filtration for company ID field. And for this company ID, we have indexes in Ignite. So it's important because it will not work for HDFS and Spark. Okay, this is a read example. We also investigated this case. And that's all. Now we will take a look on the results that we have for 1 terabyte of data. First of all, we used another kind of environment. So we have 8 instances, not 2. Instances will be much better. So you can see X1E to X large. That's pretty good for calculations and computes. Data sets will be many times bigger. You can see it on the screen. So it's 1 terabyte of data separated between 2 caches. Apache Ignite have 8 server nodes. Spark has had 8 executors, and HDFS had 8 data nodes. Okay, it's clear. Yeah, and first 2 examples when we load data. Loading data using the code I showed to you. So it's 2 threads, one for company and second for person. Loading to HDFS takes about 70 hours. Loading from HDFS to Apache Ignite takes only 2 hours. And it can be explained because when I load the data to HDFS, it was done in 2 threads, yeah, only in 2 threads. But when we load data from HDFS, we use 8 executors. So it was done in 8 threads. So parallelism was different. And that's why loading to Apache Ignite was faster. So it's not something that you need to analyze. It's just some information. And yes, it's a SQL query that we tested. Case like you see on the screen. Okay, and this is the results. First is when we don't use Spark, only Ignite SQL API, like we did in first, not in first and third example. And here is the results. So we run more iterations than 10 in this case. And you can see a percentiles for that iterations. In general, you see that clear Apache Ignite SQL API can execute that query in 5 seconds. Next, when we use the same, but we use Apache Ignite, but also we use Spark integration. In this case, you see that results in 3 times slower, and it's about 16 seconds. Yeah. Next example, when we persist the data in the Spark of Heap. In this case, we create of Heap, and it was a storage for the data, and also we increase a memory fraction. Yeah, and a lot of data can be evicted. You can see from these properties, and you see these results. So in general, this SQL query was executed in 27 seconds. Yeah, and also we spent about 15 minutes to create a cache for HDFS data. So it's much slower than in previous example. Okay, but you will see the difference, yeah, with the next slide. And it's when we just read from the disk. During that benchmarks, data was sorted, and we use a good disks. It's IO1, as I remember, not GP2, and you see the results. So these results in 2 times worse than in previous slide, and a lot of times, I guess in 10, maybe 11 times slower than clear Ignite, and in 3 times slower than when you use integration with Apache Ignite and Spark. Okay, and on the next slide, I will try to explain these results. Not on the next. On the slides, you see a graphic. Yeah. For each case. And on these slides, I will try to explain why Apache Ignite can improve these queries. First case can't be applied because in our case we have ordered data, but in case if we will have unordered data, it will be much slower. So some SQL queries wasn't able to be executed in case of unordered data stored in HDFS. So that results we didn't provide, but it's very important. Yeah. And why data should be ordered? First of all, it's related to that fact that Spark don't support SQL indexes. And when you run some filtration, yeah, for example, when you set that some field should be greater than 10, it's very important to have the correct order for this field, because in this case, it's much easier to filter the values. Yeah. So why Apache Ignite can help here? First of all, you can forget about order of the data, because when we insert the data in SQL table in Apache Ignite, it will use index binary tree, and it will be easier to find the place where the entry should be inserted, and also it can help to fastly find the required value, so binary search, etc. Yeah. Next, when Spark by default use join on some data sources, these data sources often is not collocated. Yeah, so you need to make repartition, for example, and this operation can take a lot of time. In Apache Ignite, you can create a configuration, for example, to collocate your entries from different SQL queries together. It was explained by me in previous slides. And last one, when Apache Ignite can improve your Spark SQL, is when you need to update a particular record inside your data source. Not all data formats in Spark supports random access to data, yeah. And because Apache Ignite has indexes, it can be easily done in Apache Ignite. So in case if you need to update only one entry, you just need you just can use the indexes for it. You should not scan all the data source to find this entry. Also, some Spark formats is immutable, yeah. And in this case, such modification of one entry also can ask you to recreate the source, and it can be very expensive. Okay, yeah, so this is 3 main reasons. So in case if your case can be related to some of these reasons, I guess Apache Ignite can improve your queries.